Okay, all right, so this is the next example. So this is going to be slightly different, okay, but I'm still going to kind of walk you through it, and then after this day, you'll just kind of need to understand what the steps are kind of on your own, okay? All right, but for now, I'm going to show you how to do it. Okay, all right, let's get another color that looks fun. How about green? All right, so ammonia NH3 for fertilizer is made by causing hydrogen and nitrogen to react at a high temperature and pressure. How many moles of ammonia can be made from 4.2 grams of nitrogen gas? Okay, so see, this is the problem. Not the problem, but this is what's different now. They're not telling us how many moles in the given. They're telling us how many grams in the given. All right, so you can probably guess that that's not going to work, because whenever you use the BCA table, okay, must be in moles. Okay, so using the BCA table, everything in the BCA table has to be in moles. Okay, if it's not, then you have to make some kind of adjustment at the beginning. Okay, all right, so first you need to find out how many moles of nitrogen gas you started with to use in the BCA table. All right, so we're going to do exactly what we just did in the last videos, but we kind of have to do it first now. Okay, so I'm going to have 4.2 grams of the N2. Okay, and now I need to multiply by the molar mass to find out the moles of N2. All right, so the molar mass, nitrogen, is 2 times 14.01, which is 28.02 grams per mole. Okay, so you have to find the molar mass of N2. Now here is my ratio. Okay, but remember, here I have grams of N2 is on the top now. Right? So I'm going to want the grams of N2 here to be on the bottom so that it cancels. Okay, so we've done this quite a bit, so hopefully you remember. Okay, and then the 1 mole goes on the top. Okay, so remember, it's always 1 mole. That's the definition of molar mass, the mass in 1 mole. Okay, so those are going to cancel. Okay, so now I'm actually dividing by the molar mass number. This is going to be super tiny number. Oh, not that tiny. 0.15. Okay, we're just going to kind of round it. You know, we don't really do much with significant figures at this level, which is fine. Okay, so let's just give it 0.15, which is actually the right number anyway. Okay, yeah. All right, so now I'm set to go. Now I'm ready to start. So now this is just like the last problems with the given amount of moles. You just had to make one step before you could start. Okay, all right, so let's go ahead down here and balance this. So I see over here 2 nitrogens, 2 hydrogens, 1 nitrogen, and 3 hydrogens. So I recognize that 3, 2 kind of as the first problem that needs to be addressed. So I'm going to go 2 and 3, so they both get 6. Okay, which gives me 2 nitrogens, and that's what I already have here, so that can just get a 1. Okay, all right, now I'm ready to start my BCA table. Okay, because now I have my given 0.15 moles of N2, so that's going to be my before here. Okay. And then I'm going to use all that up to come up with nothing left over. Okay, so remember, the change line's the important one. Here's the given, so everything's going to be based on that amount. So I'm going to have 0.15 here, and then my product, I'm going to add 0.15 and the ratio. Okay, all right, now hopefully by now you're getting good at doing these ratios, right? Once you, whoa, what was that? Uh-oh, oh, that happened. Oh, phew. Okay. All right. Now you get good at the ratios. Hopefully you just have to practice these. Once you get into the habit and practice them, they're going to be fine. Okay. But it is going to take some effort. Okay. So since this is 0.15 moles of N2, I want the moles of N2 to go on the bottom. Okay. So that's going to be a 1, right? And then I'm going to carry down these coefficients here. Okay, because I'm expecting this number to get bigger for hydrogen, because for every 1 of these, I need 3 of these, right? So basically, I need to triple it. For every 1 nitrogen, I'm going to make 2 ammonia, so basically, I'm doubling that, right? So those numbers are going to get bigger. Okay, so 0.15 times 3 is 0.45. Okay, so that means I had to start with 0.45 if I want this to be perfect. Okay, notice, see how this is tripled? This is tripled, this is tripled. Okay, the product, I'm not going to start with anything, but I'm going to add 0.15 times 2, so I'm going to add 0.30, and I'm going to get 0.30. Okay, which again is double what I started with, because these coefficients are 1 to 2. Okay, type of reaction, hopefully you recognize this as synthesis. Okay, and then you're going to go ahead and write your word equation, okay? And go ahead and just use the moles for the word equation every time because that's just going to be a little bit simpler, okay? 0.15 moles of nitrogen combine with or react with 0.45 moles of hydrogen, right? 3 times as much to form 0.3 moles of ammonia, okay? Remember, if it's a weird name, I'm probably going to give it somewhere in the problem, so look around, okay? It's probably there somewhere, okay? Good. All right, now, if you want to make it even more complicated, on the back end, I can ask you to do the same stuff we just did before, okay? So you could either have to do that mass conversion on the front or the back or both, okay? So here, what mass of hydrogen is needed to completely react with the available nitrogen, okay? When I look at the BCA table, I see I need 0.45 moles of it, right? 3 times as much of hydrogen, okay? Now, I want to think about hydrogen's molar mass, because it's diatomic, okay, 2.02 grams per mole. So think about where does it need to go. I have moles of hydrogen here on the top, so I need to put the moles on the bottom here, okay, because I want those to cancel. Okay, and then 2.02 grams of hydrogen up here. So 0.45 times 2.02, I will need 0.91 grams of hydrogen. Okay. All right, so it's the same exact stuff that we did yesterday, except for you may have to do some molar mass conversions either on the front or the back, okay? And the important thing is that the BCA table must be in moles. Okay, so the gram converting stuff happens outside of the BCA table, okay? The BCA table itself has to be in moles, okay? All right, so now you're going to do practice problems. I think I gave you 4. Let me see. How many did I give you? 1, 2, 3, 4. Yeah. Okay, only 4, so hopefully they're not too awful, okay? And you need to submit this. Ideally, I would try to submit it Wednesday night, okay? That's the day of class. But you can have until Thursday night until it's technically late, okay? But just make sure everything with this by the end of this week, make sure you get this because next week it's going to be a step harder, okay? So please, if you need help, please, I need you to contact me and we can meet. I'm happy to meet with you and help you, okay? But you need to contact me, okay? All right, best of luck.